Okay, right. I did a video, a live stream. It's a video right before this one, so go and look on my videos, uploaded videos, and look for the most recent one where it's titled measurements or um measurement testing, whatever, blah blah blah. I forgot what I've called it now. But anyway, this is a follow-up video I'm making with my phone. Because the resolution is just terrible actually on that live stream for some reason. I don't think it's something to do with my internet provider or something. I just don't seem to have the bandwidth. I just don't get it. What's going on with that? I am using Minicam though, and it's the older free version, and it's probably that's downsampling or something. But anyway, now I have got all four actuator coils wired up right now. I've got the big light turned off because I want to see how much, you can see how much light's coming from these LEDs which are being driven by the secondary coil. Now, as I say, this is a follow-up video to the live stream, so if you don't know what I'm talking about, you probably need to go back and watch the live stream first and then come back to this, because this video is simply to try to clarify and make a little bit clearer some of the details which didn't show up so well on the live stream. Now, this is my full wave rectifier circuit, and the AC comes in and because of the frequencies, rectifiers sometimes have problems rectifying certain frequencies, so I've got capacitors across the AC, right? So the secondary coils, when they come in, oh, actually that's the point. Yeah, I need another capacitor across the other secondary coil because I haven't got one across there, the other one. That's another thing I need to sort out. Let me just put the light on a minute. I'll just pause a minute. Right, well, the capacitors smooth out the AC a little bit. Now, I haven't got one across there, so I need to add one to that as well. It just clips off the high peaks. Now, what I'm talking about is if you look at the oscilloscope, the input is the yellow, the output is the blue, right? Now, this is the yellow, now this is the input. I'm putting 10 kilohertz coming in, pulse width 84 microseconds, peak to peak 46.4, 46 volts, peak to peak. The output is 10 point, yes, the same as the input really. The maximum voltage on the output is 28.8, peak to peak 47.2. Now if you look at the input, the peak to peak on the input is 46, right? The output is 47, right? Okay, input 46, output 47.2. Remember, this coil is not loaded down, by the way. If you watch the previous live stream, you would know that I'm measuring this as unloaded, because there's 4 secondaries, that's the output, and the cyclic RMS is 9.2 RMS. Now, that's the waveform. Okay. Right. Now you've seen that. Now, there's 4 secondary coils. There's 2 actuator coils in the center here. 1, 2. Right. These are the actuator coils. The secondary coils are 1. You can't really see it properly. 2, 3, 4. Under here. This is the 4th one down here. Now, there is other actuator coils on here which I didn't really describe. I just said they weren't connected. These are these 2. Now they are connected right now. I've connected them up. The wires are connected to this here and to this green wire, which loop around, come back down to the actuator coils that are connected here. So they're all connected to, basically, that's why all these clips come together, because these are clipped onto the actuator coils in the middle. That's my scope probe, which is the yellow trace, which we were just looking at, is connected to here, and also it's the ground wire is connected to there. So the actuator coils in the center are actually connected to the yellow channel, which is this one. Right, so as I was explaining on the live stream, when I short out the secondary coils, we don't see much of a difference on the load factors on the input. Now, looking at the current consumption, the total current consumption, right, at the moment, it is 100 milliamps. Minus, I think it's 43 milliamps, because that's what the circuit board, this circuit board here, consumes. Now, to show you what I mean, I'll disconnect this wire, and you'll see the output go off. Oh, hang on a minute. Where's my LED? I can't seem to get it out. There it is. Right, if I disconnect this wire here, the output's gone off. The circuit board is still running, and the current consumption now to the circuit board is 10, 20, 30, 45 milliamps, right? So the circuit board, this thing, consumes 45 milliamps before it's done anything, before it's done any work. Now let's connect this back up here again. Now I'll go back over to my meter, and we are at 100 milliamps, okay? It's drawing more current now than it did on the live stream, because I'm now driving not 2 actuator coils, but I'm now driving 6 actuator coils. So there's these 2 little ones, and there's a lot of losses actually between here. Let me get more. There's a lot of losses actually between here and the actual the concentric magnets that are in there and in there. So there's quite a lot of loss in this section here. So I am considering making some more of these actuation coils, but have them stacked right up close to the actual secondary coils, but with another on the other side of the concentric, which is actually right under here. So I'd have to stack the other actuator coil right above the concentric magnet assembly, which is right under here. The concentric magnet assembly is simply a bunch of magnets in a circle pointing inwards. This is why it's called concentric. You point towards the center, basically towards a ferrite core like this, right? This is a ferrite core inside there. And I'm using these bobbins, and the ferrite core fits inside there. Hang on a sec, I'll show you. Right, well, basically the ferrite cores all the way through the bobbins. I can't push this one, it's too tight. But they go all the way through on these bobbins and through the middle of the concentric, right? Okay. Anyway. So this is driving output, and when I put a load on one of the secondary coils, short it out with a 10 ohm resistor, as you see in the live stream, it consumes about 42 point something milliamps. I can't remember exactly. But anyway, when I load down all of the coils, all 3 coils, because only one coil is not connected to this circuit, and that coil is connected to the oscilloscope, which is giving me my waveform, so we can have an unloaded coil to measure it, to see what changes happen to the waveform when I short out the other coils. Now, when I get my, let me just get my meter. Okay, right, now I've got my meter, and it's on DC, 200 milliamp range. Now when I short out the DC output on the circuit, the LEDs will go out, but the other coil that is not connected directly to these, that's the other secondary coil, which is over here, which is connected to the oscilloscope, which is the blue trace, does not change because of the way the concentrics isolate the lens effect. Now, let's see. I'm not saying it's perfect. There's more work to do. Right, I'm going to connect the negative to the negative of the DC output of this rectifier board. There's 6 full wave bridge rectifiers on here. Now when I connect this, the LEDs are going to go out because I'm going to be consuming power. At the moment there's nothing on there. Now let's connect this other lead. Let's just back out a bit. Ah! Damn it, it's moving with me. Right, come on. Okay, now that's the output. That's how much power I am draining out of those 3 coils now. 123.6 milliamps. That is DC. That is going directly into my meter right now. Now, the current consumption on the power supply has gone up a little bit. It's gone up by a factor of 10, 20, 30, 40 milliamps. Right. Okay, so it's only gone up by 40 milliamps, which means that I've got a partial lens isolation, because otherwise I would have expected to see 120, more than 123 milliamps on my power input circuit being consumed. But now this is directly coupled at the moment. I'm just going to disconnect that and put my resistor on the end of this probe like this, and this is a 10 ohm resistor, right? So I'm now going to connect this onto the, I hope it stays on. I've got a clip on the end. Right, it's on. Now there's a 10 ohm resistor which is real power now shorting it out, and we have a load factor of 110. 110.7 milliamps is being now consumed from those 3 coils. As I said, the 4th coil, as you can see on the oscilloscope, has only dropped a slight amount. There's still power there. 28.2, peak to peak 50.6 volts. We've got a cyclic RMS of 9.2 volts, which is hardly any different, right? The current consumption on my input power supply has gone up to 110, oh, I can't keep still, 110, 20, 35, 135, so it's gone up by 35 milliamps, right? 35 milliamps. Now that is the second, that's the 4th coil, which is not connected to anything but the scope. Now let me just disconnect that short circuit and we'll have another look. I've taken the resistor off. Now let's have a look at the scope again. The output. This is the 4th coil again. 28, 29.8, peak to peak 47.2. 9.2 cyclic RMS. Right, that's the output is the blue. Right. Now let's look at the power supply input. We're at 100 milliamps. So the question begs really is, interesting that I'm only drawing an additional, what, 30 odd milliamps when I've got a 10 ohm resistor across all 3 coils. Anyway, thanks for watching.